Hello, and thank you for joining me. In this video, I'm going to walk through solving problem 2 from my list of hard problems at SQLshortreads.com. For the hard difficulty problems within my learning portal at SQLshortreads.com, and those you face on other learning platforms and even in interviews, I recommend translating each prompt or business problem into a data problem as you read the prompt by extracting the key pieces of information. Let's do that now. The organization has decided to start a mentorship program next month. This program is spearheaded by John Wayne. In order to kick off the mentorship program, John needs a list of mentors and mentees. He has decided that for the first iteration of the mentorship program, mentors would be the most senior employee by hire date for each job, and mentees will be the most recently hired employee for each job. Mentees will be assigned a mentor with the same job, and mentor-mentee assignments will be made only for those jobs with at least 2 employees. Let us pause here for a moment to talk about what we know so far. We know that John needs to pair up mentors with mentees based on each employee's hire date and job. For each job, we need to determine which employee was hired first and pair that employee with the employee hired most recently. Additionally, an employee can't mentor themselves. Continuing the prompt from where we left off, only one mentor-mentee assignment per job is necessary for this iteration of the mentorship program. John has requested that you generate a report containing the mentors and mentees based on his criteria. Include the mentor's employee ID, mentor's job ID, mentor's hire date, mentee's employee ID, mentee's job ID, and mentee's hire date in the report for additional context. Ensure the report is sorted by job ID ascending. Based on the last 3 sentences, we now know that the report should only contain one mentor-mentee pairing per job. We also now know the expected content of this report in terms of attributes or columns and the way the report should be sorted. Again, continuing with the prompt, in the instances of multiple mentors, mentees, or both, having been hired on the same date and for the same job, the solution does not need to produce deterministic results. The final sentence informs us that we do not need to develop a solution that addresses instances where multiple mentors and/or mentees were hired on the same date. In those instances, our solution simply needs to ensure a mentor-mentee pairing is included for each job with at least 2 employees, and that the pairing consists of an employee that has a hire date value equal to the oldest hire date value among employees for a job, and another employee with a hire date value equal to the most recent hire date value among employees for the same job. Okay, we have read through the prompts and extracted key pieces of information along the way. Before diving into developing a solution, let's take a look at the tables required for this problem and the expected output. All right, so according to this prompt and the tables required section, we only require one table to solve this problem, and that's the employees table within the HR schema. Let's check out the contents of that table. It's livesql.oracle.com. You can also review the contents of each table required for my practice problems on the practice problems homepage here. If you scroll down, you're going to notice that I begin to list out each schema and the corresponding tables. I also provide the contents of each of these tables, a description, the primary key, foreign key, etc. I do that for every table that is used to solve my practice problems. All right, so let's return back to livesql.oracle.com. We've written a short query to return the contents of the employees table. And just a little hint here, in the employees table, and you may have already ascertained this based on your knowledge of relational data modeling, this employees table is going to contain 1 row per employee. So the granularity is 1 row per employee. And for example, we have Stephen King, who has an employee ID of 100, has an email of sking, and so forth. These are the columns or attributes that are captured for each employee. And if we go back to the prompt, we quickly realize that we don't need the vast majority of those columns, right? We need the mentor's employee ID, the mentor's job ID, the mentor's hire date, and the same columns for each mentee. Now, your intuition or spidey senses are probably tingling right now because you are realizing that you need to capture data that exists across multiple rows in a single row. And based on your experience, you're probably thinking, hey, this is a job for the self-join. And you'd be right. This is definitely a job for the self-join. We'll get to that here in a moment. But what we want to do here first is break this problem down into a couple of sub-problems and solve those individually. So how would we go about this to break this problem down into those couple of sub-problems? Well, first, we need to be able to write a query that's going to identify our mentors and another query that's going to identify our mentees. All right, let's start off by writing a query that generates our list of mentors. We need 3 attributes: the employee ID, the job ID, and the hire date. Let's go ahead and fully qualify these. And run the query to make sure that it works. And it does. So we get 1 row per employee and the corresponding desired attributes of employee ID, job ID, and hire date. Now, we need to among these 107 employees, we need to pick out which ones are the mentors. And a mentor, again, just to remind us of the definition of a mentor, the mentor is going to be the most senior employee by hire date for each job. So we need to implement some strategy that's going to allow us to take those 107 employees and pick out 1 mentor per job. One method we can use to go about doing that is using a window function. In this case, I'm going to use row number. I'm going to say over. I'm going to say partition by HR of employees .job ID. So why am I partitioning by job ID? I'm partitioning by job ID because the requirement for determining mentors is that we want to determine 1 mentor per job, so for each job. So how does doing this achieve that? Well, if we're going to apply a row number or a consecutive series of integer values across rows, well, we want to make sure that we set aside each group of rows based on the same job ID value. So for all of my programmers, for example, we want to set those rows aside and then apply the row number function to those rows independently of the rest of the rows corresponding to each job ID. So what we're going to be doing is we're going to take these 5 rows, so these 5 programmers, set them aside, apply the row number function across them. But how are we going to assign these integer values, right? So how do we know which row gets an integer value of 1, which row gets a 2, and so forth? Well, because we're trying to identify mentors, and the mentor is defined as being the employee among those employees sharing the same job ID value that was hired first or the earliest, well, we're going to want to order those rows by the hire date in ascending order. So I'm going to say hr.employees.hiredate. And then I'm going to call this, just say hire date sequence ASC. So if we run this, we're going to see now that we have a hire date sequence ascending attribute that is responsible for tagging each of these rows with consecutive integer values based on the order in which the employee was hired among those employees for each job ID. So again, if we go down to the programmers, let's focus just on these rows here, so these 5 rows. You'll notice the programmer that was hired first was assigned an integer value of 1. The programmer that was hired second was assigned a 2, and so forth. And that's what we want, right? So now we have an attribute that is going to be able to tell us who was hired first and, consequently, who was the mentor. We can filter to those rows, right? So for each job, we can pick out that employee that satisfies the criteria of being a mentor. That is, they were hired first among the employees with the same job. So what we're going to do here is we're going to need to wrap this, right? So to actually filter on an attribute that is derived in the select clause, we're going to need to either treat it as a subquery or somehow, filter in the where clause that appears outside of this select statement. So what we're going to do, because this is a problem that we're trying to break down into a couple of sub-problems, I'm going to opt to use a CTE. And I'm going to call this CTE. I'm going to call this CTE mentor. So I'm going to say mentor as, let me fix these parentheses, and then I'm going to indent this, then I'm going to close this, and then I'm going to say select, I'm going to say mentor dot employee ID, mentor dot job ID, and mentor dot hire date from mentor. So let's look at this entire query real quick. So we have a common table expression called mentor, and that common table expression is defined by the output of this query. That output of this query is, as we saw just a moment ago, one row per employee, and we have the attributes employee ID, job ID, hire date, and then a derived attribute that is responsible for tagging the rows. So tagging each row based on the sequence in which the employees were hired among those employees sharing the same job ID. Now, the reason we're doing this again, right, I'm putting this in a, wrapping this as a common table expression, or, if you want to use a subquery, you could do that too. It's going to achieve the same thing. It's because I want to filter to those rows that satisfy the criteria of being a mentor, or those employees. I'm going to say mentor dot, I'm going to say hire date sequence, right? So I need this. I need to be able to filter on this. I'm going to say where it equals 1. So by filtering to those rows where the hire date sequence ascending value is 1, we are picking out the mentors, right? So the employee that was hired first among those employees with the same job. Let's go ahead and run this. And let's go down to the programmers just for as an example. We'll notice that the program, again, employee 105 was picked out as being the mentor in this case. If we go back, just to confirm what I'm showing here, let's just run this again. Just the CTE, the unfiltered common table expression, mentor, and go down to programmers. And let's just look. Okay, so the first employee hired as a programmer was employee ID 105. Let's just do another one, right? Let's do another one that has multiple employees. Let's do financial accountant. So the financial accountant that was hired first was employee ID 109. So 109 and 105, we just remember those two things just to spot check the validity of this query. So I'm going to run this. Let's see if I can get it to run. Okay, there we go. And so we were looking for 109 and 105. So for financial accountants, we should see 109. And for programmers, we should see 105. So those are the mentors for those two jobs. And likewise, each of these rows represents a mentor. Now, some of these rows are associated with jobs that only have one employee under, that's assigned to them, right? So for example, the president of this company, there's only one president. So there's only one employee. And consequently, that employee by default is going to be the mentor, but there's no mentee. So our solution in the end here is going to solve for that problem, right? Because part of this prompt's requirements, or this problem's requirements, is that we only create these pairings that are logical, right? So only create a pairing for those jobs where there's at least 2 employees assigned to it. All right, so moving on, we solved for our mentors, right? So we know that we can pick out our mentors using this common table expression and filtering to where our row number function evaluates to an integer value of 1, right? It assigns the row an integer value of 1. Now, we've done a lot of work here. We've only solved for the mentors, but if you think about it, how can we take this same exact query and change just one thing to get the mentees, right? There's literally one thing that we need to change in this query to get the list of mentees. And that one thing is going to be the way we assign integer values with this row number function. So instead of assigning an integer value of 1 to the first employee hired among those employees hired for the same job, we're going to assign the integer value of 1 to that employee that was hired most recently. And the way we're going to go about doing that is we're just going to change the order by specification here to be descending instead to get the most recent employee hired. So we're going to sort the records belonging to each partition. So those employees sharing the same job, we're going to sort them based on their employee hire date in descending order. So the most recent employee hired will be assigned an integer value of 1. The second most recently hired employee will be assigned an integer value of 2, and so forth. So what we can do is, this is some copy pasta type of stuff. I'm just going to copy that CTE. I'm going to call this mentee. And what we'll do is we'll change this to descending. And we'll just run this, right? So I'm just going to run this to make sure there's no errors in it. There's not. We'll go back down to the programmers, right? So we go back to the list of programmers, and you'll now notice that our previously identified employee as being a mentor. So the employee we identified as being a mentor in this CTE here is now being assigned, not being assigned a mentor, right? So we have the mentee being the employee that was hired most recently. So that value is assigned to 1. So the most recent hire date value is a 1. And the earliest is assigned the highest integer value among those integer values that correspond to employees with a job ID value of IT prog. So it's just flipped, right? We just flipped it on its head here. The sorting is the only thing that made the difference here. That's the only thing we've changed. So it's quite straightforward. We've simply changed the specification for the window function. Now, the hard part here is not, and was not, identifying, well, to me at least, was not identifying the list of mentors or who's a mentor and who's a mentee. It's actually going to be capturing these two result sets, so these data that exist across multiple rows, in a single row, right? So because for our mentor-mentee pairings, we want to represent that relationship or those two records, those two employees within a single row. And I spoke about it earlier, self-join, your intuition should be, like your spidey sense should be tingling here. Self-join is going to be the tool for this job. And what we can do here, we know that we need, based on this expected output, right? So the expected output, we're going to list the mentor's information first. So the mentor's employee ID, job ID, and hire date, and the mentee's employee ID, job ID, and hire date. So what we can do here is we can do the same thing in our select clause outside here. I'm going to say mentee.employee ID, mentee.job ID, and mentee.hire date. So let's just go ahead and do the hard part. So previously, when I ran this query, I was selecting just from mentor, just to showcase that this predicate or this filter in the where clause was effectively filtering to those employees that were hired first among those employees with the same job. So that gave us our mentors. But now we need to get the mentees, the list of mentees, and stitch those together. So create those pairings within a single row, represent the relationship of this mentor-mentee program, and assignments within a single row per pairing. So what I'm going to do here is I'm going to say inner join mentee on mentor dot job ID equals mentee dot job ID. So why am I choosing job ID to join on? Well, we're creating one pairing, and that pairing between mentee and mentor is going to be based on them sharing the same job ID, right? So I'm going to take each mentor, so one mentor per job, and pair them up within the same row. So stitch their data together. So stitch the result sets. So stitch these two result sets. So take the output of this query and take the output of this query and stitch them horizontally together based on records that have the same job ID value. Because I want to make these pairings, right? So these pairings between mentor and mentee, they need to have the same job. So I'm going to say on mentor.jobid equals mentee.jobid. And then what I'm going to do is I don't want to include those jobs. So I don't want to try to create a illogical mentor-mentee pairing with the same employee, right? If I don't somehow put in some mechanism that excludes those jobs from our result sets that only had one employee, then I will get a mentor-mentee pairing that has the same employee for the mentor and mentee. So what I'm going to say is, I'm going to say and mentor.employee ID does not equal mentee.employee ID. So this is going to take care of those scenarios. So avoid having those jobs where there's not at least two employees in our out result sets. And then the final thing I need to do here is I need to, so previously we filtered to our mentors of this result set, right? So how we identified our mentors was we selected those employees that had a hire date sequence ascending value of 1. We can do the same thing for mentee, right? So we need to say and mentee.hire date sequence equals 1, because this is going to be descending, and I should have actually named this differently. So let's just go back up here. When we changed this, we also need to change this. This makes more sense to call a hire date sequence descending when we're actually sorting the records or the employees based on their hire date in descending order. And for the sake of this query working properly, we also need to do that. So we have mentor.hire date sequence ascending is equal to 1. So those are our mentors amongst the employees returned by this results set or that query, and the employees with a hire date sequence descending, which are our mentees based on this result set. And we're again, based on this join clause here, we're going to be able to horizontally stitch those two things together to represent this relationship or this mentor-mentee pairing within a single row. So if I run this, we're going to get that. And what I'm going to prefer to do here, I'm going to run it, I'm going to keep it in the where clause here. We don't technically need this in the where clause, but I'm going to keep it in there for now. What we're going to see here is we have 9 pairings, so 9 mentor-mentee pairings. And now you'll notice that so for our mentor is employee ID 102, and our mentee is employee ID 101. And this pairing is based on the job ID of administrative vice president. So this is the single mentor-mentee pairing for this job. This is a single pairing for this job, and so forth. So what you should see is you should see 1 row per possible pairing, so per job that has at least 2 employees. And that's what we see here. One additional thing that we need to do here, because for the sake of actual, ease of use and actually consuming this report, we need to tell our users, okay, which one's the mentor and which one's the mentee, right? Which attributes or columns correspond to the mentor's details and which one to the mentees. So we're going to do this. We're going to say as mentee, I would say mentor ID, as mentor job ID, as mentor hire date, and finally as mentee hire date. So if we run this now, we're actually going to be able to distinguish between mentor and mentee as far as the attributes go. This makes this report a lot more easier to use, right? We don't want people guessing, okay, which 3 columns correspond to the mentor, which 3 to the mentee. So there you have it. We solved this problem. One thing I'd like to leave you with is if I'm writing this query and I'm using inner join, I'm probably going to put this in here. I'll probably keep it like this.
If you enjoyed this video, then please like the video and subscribe to my channel for notifications on future videos. Thank you again, and see you next time.